noticed you guys had a little bit of trouble with the quiz on lessons 1 through 4. So I'm going to pop this video up here to go over the problems so we can prep for our test that's coming up fairly soon. All right, so in this first one, you had to decide if the shapes in the little grids were similar. So we know similar shapes have to have congruent corresponding angles and proportional corresponding sides. So the key here was to check the corresponding sides to see if they formed a proportion. So this side and this side look like they correspond. So that'd be 4 to 1, 2, 3, 4, 5, 6, 7, 8. And this side to this side would be 1, 2, 3 to 1, 2, 3, 4, 5, 6. So 3 to 6. Are those congruent? Are they proportional? Yes, they both simplify down to 1/2. You could also check cross products to see if they are the same in 24 and 24. Okay, so this we would drag in there and put similar. All right, now let's look at the next one. Here we have that would probably correspond with that up there. So 3 to 5 would be the ratio there. 1, 2, 3. Oh, I counted wrong. Let's get rid of that. Oops. Okay, 3 to 4. And we'll go with this probably corresponds with this. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. So that'd be 5 to 7. Those are not equal. You can see the cross product there's 21, the cross product there's 20. So they are not equal. So these are not similar. Moving on, we have to check this one. This one's a little bit more difficult to check. What I would suggest when you have lengths that aren't right along the grid lines, so they're harder to find, is that you use heights of triangles instead. All right, heights of triangles instead of just like the side lengths. Okay, so let's check these corresponding measurements. So 1, 2, 3, 4. So that's 4 to corresponds with this base here. 1, 2, 3, 4, 5, 6. And we're going to check to see if that's equal to the ratio of the heights, which is 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. So they do correspond. The corresponding sides are proportional, or dimensions are proportional. All right, so that would be similar as well. And then we have this last one, and again, it's going to ask, we have some diagonal lines, so they're a little bit harder to check. So instead of checking those, we'll check the heights. All right, so let's find this corresponding side to this corresponding side. That's 1, 2, 3, 4, 5, 6. That's 6 to 1, 2, 3, 4, 5. And if we check the heights of these parallelograms, we get 1, 2, 3, 4 compared to 1, 2. So that'd be 4 to 2. And these do not create a proportion because the ratios are not equal. That'd be 12. That'd be 20. So no. So this is not similar. I'm outside because I couldn't stay inside. I'm standing up because I couldn't sit down. So I'm sorry if you hear the helicopter above and people talking in the background and birds tweeting and me walking. But just had to get outside. All right. So that was that one drag and drop problem. And now we'll look through some of the other problems. These ones are a little bit more straightforward. So determine if two figures are congruent by using transformations. So just by your eyeballs, it looks like these are congruent. How would you map the one onto the other? A reflection wouldn't do it, right? If I reflect this shape, it would either look like that or it would look like that. So reflection won't do it. It's not a mirror image. Dilation, it's not a different size, so no. So it looks looks like it's going to be congruent because of a rotation. All right. Now this one is tricky. You could have gotten several different answers and they could have both been correct. The only one that I would say, well, there's two that aren't correct. They are congruent. They look congruent. And C, it says a dilation. And that would mean they'd be different sizes. So we don't use a dilation when we're talking about congruence, where we use a dilation when we're talking about similarity. So that leaves these two. And if you got either of these right, you should have gotten it right, because I think there's an argument for both. Congruent, a reflection followed by a translation. Okay, you could reflect it like up here, so it went like that, and then you slid it over. So, or you could have reflected it over that line and gotten something like that. Okay. Well, I guess you wouldn't do that, because then if you translate it up, so you just start with that first one that I did, where you reflected it vertically over a horizontal line. All right, so you could have done that. Or if you did a rotation, you could have done that as well, I think. Let's see. You could have like rotated around this point, so it looked like that, and then translated it over. So you could have done that as well. All right, so that or that. I got to go back and check and see who chose one, maybe chose the right answer, but it marked it wrong because it is a dumb problem by the book. Anyway, so looking at number 3, we got two shapes that are different sizes, so automatically I know they're not congruent. Right? They're similar, not congruent, so this is a not congruent there. Okay, you might have said, oh, congruent, and you saw dilation. Maybe you got confused there, but the word should have been similar. Okay, so that one was kind of like a trick question. All right. Write congruent statements. Compare the corresponding parts in the congruent triangles shown below. All right, well, you just had to match up the things with the same number of lines. So you can see J and Z are corresponding. You can see F and X are corresponding, and you can see G and Y are corresponding. So let's see. And congruent, for that matter. All right, so X and J are X and J, X and J. X and J are not. So this is not. X and F, let's see, X and F, X and F. Oh yes, that's right. So Y and G, let's check that. So I'm checking this one now. X and F, good, we checked that one. Y and G, yep. Z and J, yep. Okay, so far so good. We've checked these guys. And now line XY. Line XY is up here, and it goes from the right angle to the acute angle there. So, and let's check it with FG. FG. XY, FG, yep, that's good. And then YZ is here. And YZ, so GJ. GJ is here. Yes, good. So we got those guys. And then last one, ZX and JF. ZX and JF. Yep, okay. So B is good to go. All right, cool. Okay, the pair of polygons is similar. Find the missing side length. So what you had to do is set up a proportion. All right, and we had a missing side length of X. So if we want to put that here, so what's that correspond with? That looks like it corresponds with this guy up here, right? It's kind of like the longer side. It goes from the triple arc here to the double arc, and the triple arc to double arc there shows me that those are the corresponding sides. So the smaller to the larger shape, we could do it either way, but we just have to be consistent. So smaller to larger shape, x over 18. Now we have to find a pair of corresponding sides that we know both of. So a nice easy one would be 3 to 6. Those correspond, and smaller to larger would be 3 to 6. And it looks like there's a relationship of from 3 to 6. It looks like double. So what number doubled gives you 18? Well, x would have to be 9. Okay, or you could look this way and say times 3, so times 3. Or you can do cross products and set up a proportion, or set up a new equation to solve with cross products. Okay, but the key is corresponding side lengths are proportional when you have similar shapes. All right, let's look. Number 6, determine if two figures are congruent using transformations. Well, guys, look at them. They don't look like the same shape. You could never spin, rotate, reflect, translate, dilate. You can't do anything to make this guy look like that guy or map on top of it. So these figures are not congruent. They don't map on top of each other. Okay, write a congruency statement comparing the corresponding parts in the congruent triangle shown. So we just have to match up everything. So B and D have to match. So let's see. B and D, B and D, B and D, B and D. Oh, every single one has B and D matching. Okay. Let's try C and E. C and E, C and E. Oh, this one doesn't have C and E. So we got that one out of there. And A and F. Oh, this one is out. All right, so we have B and D still left. So now let's work on the side lengths. Maybe I'll erase some of the stuff to get some of the craziness out of there. Okay. Let's see. AC and FE. AC and FE. Oh, nice. This one looks like it does the trick. Down here, AC and DE, no. All right, so that would be B. Okay, corresponding parts. Now, this goes back to something that I talked about earlier in this, where when we have diagonal lines and we're looking for similarity, it's sometimes hard to check their lengths because they're hard to count. We know we could use Pythagorean theorem to find them, but it takes a while. So what we'll do is we'll check all the other corresponding parts, and we'll use the heights as well, because the heights are typically along the grid line. So let's find, okay, this one we're checking to see if it's similar, so we have to figure out if the corresponding side lengths are proportional. So if we look here and here, we've got 3 compared to 1, 2, 3, 4, 5, 6. So that's 3 to 6. And if we look at the top, we have, in the top of this guy, we have 1 to 2. So 3 to 6 compared to 1 to 2, that's the same. Let's look at the heights now. All right, that's 2 and that's 4, so 2 to 4. It looks like we have corresponding parts that are corresponding side lengths that are proportional. So these are similar. So we know they're similar, but now we just have to decide the transformations that will get them on top of each other. So figures are similar, so we can cross off this one because they say the figures are not similar. So figures are similar, we need a dilation, and each of them has a dilation, so that's good. Now how are we going to get it to map? So a reflection followed by a dilation. Well, it looks like this is kind of spun, not reflected as much. So I would say that that does not work. The figures would be rotated followed by dilation, or translated followed by dilation. So it looks like we have to rotate it first and then dilate it. So that's going to be B. All right, almost there. Last one, right? I hope. Ah, we still got more. This is an eternity. All right. Are these similar? Well, that means, well, it looks like all corresponding all corresponding angles are congruent. We just have to figure out if all corresponding side lengths are proportional. So the length corresponds with the length, and if we, flip it, then this corresponds with this. So 12 to 4, is that equal to 36 to 12? And when I simplify both of these, this simplifies down to 3, and this simplifies down to 3. Yes, they're the same, so the answer is yes, they're similar. All right. So are these guys similar? Well, if they have, corresponding angles, looks like they are all matching, so that's our first check, and then we're going to find our corresponding side lengths to see if they are. So between here and here, between the right angle and the 53, so right here, the right angle and the 53, that'd be 9 to 12. Between the right angle and the 37, that's going to be 12 compared to right here, 16. And we're checking to see if these are all proportional. And then we're going to compare the 15 to the 20. And see if that matches up. All right, we got, let's see, this simplifies down to 3/4. 4 goes into that 3 times and 4 times. 5 goes into that 3 times and 4 times. Okay, so they all are equal, so they are similar, right? Corresponding angles are congruent, corresponding side lengths are proportional. Determine, find a missing, right? Finding a missing measure in these similar polygons. So we have to set up a proportion using corresponding side lengths. So we got this corresponds with this. So we can do 9.6 to 4.8. And then this guy corresponds with this. So we'll set up and do K to 3. And then we'll cross multiply and get our answer by doing 3 times 9.6 divided by 4.8. All right. And that looks like it. Okay, that was long. Hopefully you can fast forward to kind of the ones you need or the ones you didn't get. But good luck. And hopefully this cleared up some confusion. Or you can find mistakes that maybe the book made when it graded you that you could tell me about and help your grade out. Thanks so much. Bye.